Hey geometry guys and gals, we are taking a look here at a quick review of just about some areas of circles, and it kind of leads in from yesterday's Desmos activity, right? So this area of a circle, if we recall, we're going to find the area just by looking at this formula, pi times r squared, right? So now if we remember, pi is a number. It shows a relationship between certain things on the circle. And so anytime that we're asked to evaluate it or round it to a certain number of decimal places, we're going to use 3.14 for that. Now, let's just take a look here at a circle, a very nice looking circle here. And let's say that my diameter is 10, right? So if I were going to plug this in, notice I have my radius of just pi, my formula of pi, and then my radius is 5 right here, right? Remember, a radius is just halfway across the circle. So in this case, it's 5, right? So there's a couple different ways that they could ask you to leave this answer. They could ask you to leave it in terms of pi, right? That just means simplify everything else and then leave the pi symbol right there. Another way that they could ask you to do it is to actually substitute 3.14 in for that, and you would just get 78.5. Now, please be reminded that we are using correct labels. So if this was inches, it would be inches squared, right? There is no label, so I could just call it units squared, right? So whatever unit of measure it is, make sure that you include that in your final answer, right? Now here's what we kind of explored yesterday on Desmos, right? Sometimes we're not asked to find the area of an entire circle, right? So if I look at this same circle here, and instead of showing, oh my goodness, my circle gets really bad here. Instead of showing a diameter, I'll just show the radius. We'll just say it's 5. But this is really the only area that I am concerned about right here. Right? And so let's say hypothetically that this angle measured at 80 degrees right there, right? Or maybe it's labeled here on the outside. Okay, so I could take that same formula here, pi r squared, and I would times it by the measure of my arc over 360, right? So maybe this is point A, this is point B, so I could say minor arc AB is over 360. That means I'm not finding the entire circle, but what I'm going to do is I'm just going to find if this circle is broken up to 360 equal parts, because that's how many degrees are in a circle. I could just find 80 of those 360 equal parts. Alright, so again, we've already established what sum of this is, but it's 5 squared, and then it's just 80 over 360, right? This is on the top of the fraction, right? This pi 5 squared. Okay, you could use a calculator, you could start reducing, many different ways to take a look at this. For me, I would take a look at making this 25. It looks like the zeros definitely reduce, and then 8 and 36 can also reduce. If I take a factor of a 4 out, it looks like it's 2 over 9, right? So I could keep multiplying this together. Again, this pi and 25 is on top. So if it's asking for an exact fraction, I can multiply the 3 things on top. So 50 pi over 9. Okay, now what would that be? That would just be units squared. Alright, so when we're taking a look at this here, make sure that we have this type of perspective on that we're not finding the area of the entire circle every single time. You will at the beginning of today's assignment, but on some cases we're just finding the area of partial or part of the circle. All right? So take a look at those questions, and we will reconvene tomorrow.